Welcome to the second part of VCAA Mathematics 2020 exam paper series. In this video, we will present exam paper 1 questions 5 to 6. For question 5, most students recognize the use of binomial distribution, clearly specifying the distribution parameters, and they were generally able to identify that conditional probability was involved. However, common errors include the use of an incorrect formula or arithmetic errors in evaluation. Students also need to be aware of the requirement of quoting a rule or formula within the context of the question. For question 6, some students did not state the required domain correctly in part A. In part B, though the point of intersection was generally obtained correctly, it is often not plotted in the correct position. In part C, those students who took care with setting out their working and did not attempt to do several steps in one line of working generally scored well.
Hello, Math Champions. I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this Mathematics VCAA exam paper series. In this video, we will present you questions 5 and 6 of exam 1 2020 paper. Let's start from question 5. The background information for question 5 is that for a certain population, the probability of a person being born with the specific gene is 3 over 5. The probability of a person having this gene is independent of any other person in the population having this gene. There are two parts in question 5. For part A of this question, in a randomly selected group of 4 people, what is the probability that 3 or more people have the gene? Part B of this question is that in a randomly selected of 4 people, what is the probability that exactly 2 people have that particular gene, given that at least one of those people has that gene? It also requires you express your answer in the form of a cubed over the result of b to the fourth minus c to the fourth, where a, b, and c are positive integers. Here we start to answer part A of question 5. According to the description earlier, this is a binomial probability distribution related question. Given that x is the number of people in the group carrying this particular gene, and PR of x is greater than or equal to 3 is written to 4c3 p cubed times 1 minus p, or in parentheses, plus 4c4 p to the fourth. Since p equals 3 over 5, PR of x is greater than or equal to 3 equals 297 over 625 after being calculated and simplified. As for part B of this question, the probability that exactly 2 people have the gene, given that at least one of those people has the gene, is written to PR of x equals 2 intercept that x is greater than or equal to 1 over PR of x is greater than or equal to 1, which equals PR of x equals 2 over PR of x is greater than or equal to 1. Both PR of x equals 2 and PR of x is greater than or equal to 1 are calculated accordingly, as they can be seen on the screen. Here we have PR of x equals 2 equals 4c2 p squared times 1 minus p, or in parentheses squared, which equals 6 cubed over 5 to the fourth after being simplified. Since PR of x is greater than or equal to 1, equals 1 minus 4c0 times 1 minus p or in parentheses to the fourth, which can be simplified to 5 to the fourth minus 2 to the fourth, or over 5 to the fourth. The conditional probability of PR of x equals 2 over PR of x is greater than or equal to 1 is equal to 6 cubed over the result of 5 to the fourth minus 2 to the fourth. The function f of x given in question 6 equals square root of x over square root 2, and its domain is in a closed interval from 0 to 2. There are three parts in this question. Part A is to find the domain and the rule of its inverse function. Part B is to sketch its inverse function over its domain. Label the coordinates of n points and points of intersection with the original function f of x on the given axis. Part C is to find the total area of the two regions, one region bounded by the function f of x and its inverse function, and the other region bounded by f of x, its inverse function, and the line x equals 1. The requirement is also to give answer in the form of a minus b square root of b all over 6, where both a and b are positive integers. Now let's start with part A of question 6. Since the function f of x equals square root of x over square root 2, its inverse function equals 2x squared, and its corresponding domain is in a closed interval from 0 to 1. As for part B of this question, we sketch the inverse function of f of x as shown on the right of the screen. The coordinates of the intersection between f of x and its inverse function are also shown in the sketch diagram. The details of calculating the coordinates are also shown here. We set f of x equals the inverse function to obtain a quadratic function 8x to the fourth minus x equals 0. Solving the equation by factorizing the left side of the equation and the coordinates of the intersections are obtained. They are 0, 0 and 1 over 2, 1 over 2 respectively. Here we continue to work on part C of question 6. The part C is to find the total area of the regions. One is bounded by the function of f of x and its inverse function. The other is bounded by f of x, its inverse function, and the line x equals 1. Hence, the area equals the integral from 0 to half of the square root of x over 2 minus 2x squared, or in parentheses with respect to x, plus the integral from half to 1 of 2x squared minus square root of x over 2, or in parentheses with respect to x, which equals square root 2 times x to the 2/3 divided by 3 minus 2x cubed over 3, or valued from 0 to half, plus 2x cubed over 3 minus square root of 2 times x to the 2/3 divided by 3, or valued from half to 1. After substituting the corresponding values, we may perform the calculation to obtain the results. The detail of the calculation steps is shown on the screen. And finally, we obtain the result 5 minus 2 square root 2 all over 6.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.